I am from Hungary, and I work also in the EUMeTrain as a EUMeTrain trainer. So in EUMeTrain, EUMeTrain is a training project of EUMETSAT, and we have several materials which are especially about RGBs. So training modules, webcasts, and also case studies. And in EUMeTrain, we have an e-port where 3 early images are visualized. GOES images, Himawari images, and also Severi images. And these images could be combined with radar, synop, and so on data. And we have also an archive. We have also quick guides. Quick guides are published about all Severi standard RGBs and about 4 new channels of the future FCI, and also 4 quick guides on FCI proxy RGBs. And in these quick guides, the parameter of the recipe are not indicated, but we have separately a list of RGB recipes which contains the recipe of those RGB on which we published quick guides or which are included in the RGB color guide. I will show you in the next slide. And on the forum webpage of EUMETSAT, there is an almost ready extended guide on the cloud phase RGB as well, which describe this RGB much more extensively. Yes, this is about the RGB color guide. So it contains small descriptions of the typical appearance of the main phenomena in the different RGBs. So, and you can search according to the satellite instrument, RGB type, phenomena, or color. So, and each description contains text, examples, notes, exceptions, and so on, the typical colors. It is under construction, of course, always something new, and it contains presently Severi, AVHRR, and WIRS RGBs. The WIRS RGBs as FCI proxy RGBs. And I would like to speak about the RGB tool. I hope it will come. Yes, it is here. So this is a small tool. You can use it, so anyone can download it from the EUMeTrain webpage. Then you will get an Excel file and a parameter file, and you can use it to analyze or test RGB images. So it looks like this. Okay, you can choose first the sensor, for example, ABI, and then you can use the Airmast RGB. So sorry, this is an older version, but that's the main point. So you can click and drag with the cursor to go indicate any pixel, and then you will have values, and these are the calibrated values, brightness, temperature, or reflectivity, or the difference of the calibrated values of 2 channels. And here under the settings, you have the recipe, the channels or channel differences, the ranges, and the gamma values. So for this small tool, I collected a lot of RGBs from quick guides or presentation, and as I have already showed, it contains all several standard RGBs, RGBs for the AVHRR and for wheels. First of all, those which will be also FCI proxy, and also for GOES and Himawari. So, and as I said, I collected a recipe for this tool, and so we have at the moment 3 lists already, one for the quick guides and the RGB color guide, the second one for this RGB tool, and for this workshop I collected even more RGB recipe to be able to compare the similar RGB type the recipe for the same RGB type which were tuned for different sensors. And I created 2 lists, one according to the sensor type and then other according to the RGB types. So of course today I have seen that there are even more RGBs under development, but what collected those GOES and Himawari RGBs, which were also quick guide available. And I can give anybody this list. So collecting the RGB recipe, I found also challenges and difficulties. I would like to speak about two challenges. One, that we should harmonize the definition of the gamma parameter of the gamma correction. So that is the equation what we use at EUMeTrain, and this value is what the EUMeTrain people call as gamma. And as I showed in the Japanese quick guides, they use also this definition, but the American colleagues use sometimes the 1 per gamma as gamma. So also in the quick guide, sometimes I found this, sometimes the other one. So I think that we should harmonize this. What is the gamma? And so I had also difficulty with the description mode of the Japanese RGB recipe. For example, this is from the quick guide, from the Japanese quick guide, how they describe the cloud phase distinction RGB, and I adapted it for the wheels. And when I first created the RGB, it looks like this. So evidently it is too red. I had the idea that maybe I should invert the 10.8 channel. So, and then it looks like this, how it should look like. So that's why in the harmonize, how I think that the harmonized I wrote here. And as I wanted to compare the RGBs recipe created for different sensors, I had also the problem that in the Japanese quick guide, the channel difference are usually had the opposite than in our quick guides. So I had to harmonize the recipe also from this point of view. So when one RGB was adopted for another sensor, then sometimes the people used the same parameters in the recipe. Sometimes it was fine-tuned to get the similar color as good as possible, as similar as possible colors. And of course, there was also retuned or considerably modified recipe when the other groups thought that they can develop it. And it was also very interesting what was not adopted by the other for another sensor. So at the last, I would like to mention two interesting features, which is, I think, good to know. The first one is that how a color appears, it depends also on the background. For example, if I put here, you can see that they are identical color. But if I move this square against a darker background, that it looks brighter. So I think that every developer who deals with RGB should know this. And if we produce a training material, then it is also always very useful to create examples with annotation and not only the color separately. Okay. And the last point is the role of the sensitivity of the human eye. So the human eye sensitivity is not equal in the primary color. So it is most sensitive usually in the green color beam, and secondly in the red color beam. And this is has also an important role for the RGB developer, because the RGB will focus on the information what is put in the green color beam, and secondly in the red color beam. So the color assignment is important from that point of view. For example, here you can see the day microphysics RGB when it is treated with 1.6 micrometer. Here is the recipe, and this is the cloud phase distinction RGB. And if you look at the channels, you can see that they use almost the same channels. So the two physical visible channels are not the same, but if you concentrate on clouds, that they have really very similar information. So these two RGB use almost the same channels, so the information content is similar, but they focus on, because of the sensitivity, human eye sensitivity, they have different focus. So for this RGB, focuses on cloud top microphysics, and secondly on optical thickness, but this focuses on cloud optical thickness, and secondly on cloud top temperature. So if you look here, that you will see orange dots, patches in the red background. These are areas where the cloud top is covered by small ice crystals, and it is not seen here. If you look here, then you can see towering cumulus clouds, and the red one are covered by ice crystals, while this yellowish, pinkish are water clouds. So here we have good color contrast between ice clouds and water clouds. And here we have also color contrast, but not so good than here. And here we have some color contrast between water clouds with large droplets and water clouds with small droplets. And what is not seen here. And that is why I think that it focuses on cloud top microphysics. But here, if you look at that, here there is much better color contrast between thin ice cloud and thick ice cloud. And also we have more color for green and yellow are both color of ice clouds. Here we have also different red shades, so they also has different color shades, but the color contrast is not so good. Okay, and the summary, so I try to show some overview of the RGB web page, and I spoke about the challenges of collecting RGB recipes. What should we harmonize? And I intend to mention these two interesting features. Thank you.
Thank you, Maria. You brought up some very important points, and we're going to have a discussion on Thursday about standardization, and I think some of the points you raised can come up there, including this issue of gamma versus 1/gamma. I agree it's important to get that constant across and make the implementation easier for everyone who's referring to these quick guides. Yep. Any questions or comments?
Well, and I'll also add to that, you brought up the use of the term inverted and have some sort of standardization on that as well, because that has been confusing. Not only for you to put them together, but I've heard similar comments when people use the recipe and try and create their own RGBs. So thank you for bringing that up and using that. And I've already used the tool, and is this the update? Is the updated version now available, or?
So not the last one. We had two there, so.
Oh, okay. So
I will show which one is the last one.
Okay. So
but on the web page, if you download from the web page, this is the updated.
Okay.
Yes.
Okay. And I think that follows on with some of Katie's comments that people who have challenges, they also use the ranges. And I noticed when you were doing that last explanation of the different colors used, that there were also quite some larger differences in the ranges, and
yes,
that also affects
yes,
it
you
too.
are right.
Yeah. Yeah.
So, but I had only 50 minutes. That's
right,
why
right.
I didn't mention that the ranges are also not the same, but the color assignment has really a role.
Right, right. Okay. And like you said, this tool can be used on web pages, so that's the benefit of it from my point of view too. So,
Bodo.
Just a quick comment. This is actually, it's one of our regional focus group meetings that we ran back in November 2015. JMA have actually conducted a fairly thorough regression analysis comparing Himawari 8 versus MSG channels, and Shimizu-san presented that. So I just thought I'd bring that to the attention. Thank you.
Thanks, Bodo. Anything else in the room?
So thanks for your presentation, and I agree. Looks like on Thursday we can talk more about how the American Gamma became the way it did, and I look forward to telling that very interesting story. But on this topic, on the green, it's not only that our eyes are sensitive to the green, but our eyes are sensitive to changes in luminance. And I don't know how that's going to translate for people that I'm trying to figure out a different way. So in the United States, we used to have, and we still have, signs for like crosswalks that are yellow. And we're in the process of changing them to be this like lime green color so that they stand out more. And our eyes are naturally drawn to things. And I think everybody in the room, if you look at this image, our eyes are drawn to the lime green, yellow, and yellow shades on the right. And there's just a lot of it, right? And so our eyes, when we see that, are just washed out with any detail because that's an attention-grabbing color for us. So I think that this contrasts to on the left side where the red, where there is an adjustment in luminance, right? So we see the detail. I guess the question that I would have is, you know, should we be looking more at avoiding I'm trying to put the right, should we, you know, the benefit of a band like 1.6 is that it has good contrast. It has good contrast in luminance. So if that's the feature we're trying to see, should a best practice be that the 1.6 should routinely end up in the green?
If you would like to see the plot of microphysics, then 2.25 or 1.6 or the 3.9 reflectivity. So I did not show now the cloud phase RGB, but I like it very much. So it's really, yes, it's used to microphysics.
Should the microphysics be green? Should the 2 point, I'm sorry, I'm not on the microphone now, but should the 2.25 and the 1.6, if the aim is to see a variance, sorry that this is an extracted question. If the aim is to see a contrast in cloud features, so for example, I think we've established the 1.6, ice clouds are darker than the water clouds, similar in the 2.25, although the relationship is a little different. Because of our sensitivity to green, and because the 1.6 provides that contrast, should that band as a general best practice usually end up in the green? And maybe it's yes or no, I don't know, it's a thought question.
And I'm thinking you're thinking for just a limited viewing where you want to view vegetation, because clouds are not green. So,
No, well,
yeah. I'm just,
sure the
yeah.
clouds aren't green, but I think we all, sorry, I don't like it yet. But the image on the right, right? I mean, we've extolled the virtues of the cloud phase distinction RGB, whether it's adopted or not, right? I mean, we like that one. Our forecasters like that one, and but that one has the 1.6 in the blue. So, you know, but when we look at that image on the right, I mean, all I see is just a giant, if it's mature convection, it's just giant blob of yellow. And if that was trying to get my attention driving down the road, it sure would. So it's good for signs in the US. But again, I'm just thinking about as we head into best practices, if we're trying to find detail coming out of the 1.6, is the best practice in many cases going to be to put that in the green, not what color it should be. I don't know in any RGB what color something should be unless it's a natural color.
All right, quick comment by Yvonne, and then we'll move on. We could talk about this for a long time.
Yeah, I think we should take it offline or later. What we came up with a kind of standard in Europe is this actually, to put the microphysical signal on green, on red optical thickness, and blue is the temperature. Both in the day or dust RGB, even though dust RGB, when we see example from Bill, when you move the BTD from red to green, you can see dust much better because it's on the green, because what Maria was saying. But to have some conceptual consistency, optical thickness red, microphysics green, and the temperature blue. So this is what we have in Europe at least.
All right, let's thank Maria one more time. Thanks, Maria.